Everything looks fine. 4 words, 9 minutes in a room. A printed sheet, a column of numbers, a doctor scanning it and nodding. Fasting glucose, normal. Cholesterol, normal. You drove home relieved. I want to show you something about that sheet of paper. It can be completely accurate and almost useless at the same time, because your body has a talent nobody warns you about. It can cover a problem for years by working harder. And the harder it works, the more normal your results look. Here's what that looks like when somebody actually measures it. In a study of adults whose fasting glucose was only just beginning to drift, researchers measured beta cell function to insulin output, corrected for how insulin-resistant these people already were. It was down by half to 2/3, half, on the first slightly abnormal test. So the question was never, is my blood sugar normal? The question is what your body is doing to keep it normal, and how long it's been doing it. 4 minutes from now, I'm going to ask you to stand up and find a tape measure. Not a scale, a tape measure. Because in a study of 2,700 adults, a $4 strip of plastic was still standing when the scale wasn't. I'll show you exactly what it was standing on. Then I'll show you what's been happening quietly for years to keep that blood test looking clean. Let's go. Quick note, and it's short. This is education, not medical advice, not a diagnosis. If anything here worries you, the next step is a blood panel and a doctor, not a supplement, and not a YouTube video. Including this one, let me describe someone. Tell me if I'm describing you. Somewhere between 38 and 55. The scale has barely moved in 10 years. 5 pounds, maybe 8. But there was a morning, you can't name the date, when the belt went 1 notch further and stayed there. Not tighter everywhere. Tighter in exactly one place. Same body weight, different body. And you were handed the explanation before you even asked for it. Your metabolism slowed down. It happens after 30. It's just aging. That story is wrong, and we've known it for 5 years. In 2021, Herman Pontzer's team published the largest analysis of human energy expenditure ever assembled. 6,400 people, 29 countries. Measured with doubly labeled water, the gold standard, not a questionnaire. Once you adjust for lean body mass, energy expenditure is flat from age 20 to age 60. Flat. Your 20s, 30s, 40s, and 50s are the most metabolically stable decades of your life. Decline starts around 60, at roughly 0.7% a year. Real lease, but that's a 90-year-old effect, not a 35-year-old effect. They went looking for exceptions. Puberty, surely puberty. It wasn't. Pregnancy, surely pregnancy. Energy needs were exactly what you'd predict from the extra mass. No mysterious surge. Which leaves you with a much more uncomfortable question. If nothing slowed down, what moved? 2 things. Neither of them is your metabolic rate. The first is composition. Lean mass down, fat up, at stable total weight. Your scale reports one number, and that number is the sum of 2 things traveling in opposite directions. It can stay perfectly still while both of them run. The second is location, where the fat went, which turns out to matter more than how much of it there is. And that second one, you can measure yourself. Today. In about 11 seconds. Your waist divided by your height. Waist at the navel. Breathe normally. Tape horizontal. Snug. Not compressing. Divide by your height. Same units. That's the whole thing. Now let me tell you why it earned that spot. Researchers at Pitt and UPMC took a Brazilian cohort, 2,700 adults with no heart disease, followed more than 5 years, and tested 3 things against the development of coronary artery calcium. That's calcium building up in the artery walls, an early physical marker of atherosclerosis, BMI, waist circumference, and waist-to-height ratio, 3 contenders. Before adjustment, all 3 looked good, all 3 looked predictive. Then they adjusted for the classic risk factors, age, sex, smoking, exercise, diabetes, blood pressure, cholesterol. 2 of them disappeared. And then there's the detail that made me sit up. The signal was concentrated in people with a BMI under 30, below the obesity threshold, the people with every reason on paper to believe they're fine. 2 limits before you go measure, and I'd rather you hear them from me. This predicted a marker of artery disease, not heart attacks. And it's observational. It's a screening ratio, not a verdict. The commonly cited reference point is below 0.5, waist under half your height. Treat that as a conversation starter with your doctor. Now the instruction almost nobody follows. Measure it every 3 months. Write it down. One value tells you where you're standing. A trend at stable body weight tells you which direction you're walking. And the direction is the whole signal, because the most common metabolic aging pattern on Earth is a waist that grows while the scale sits perfectly still and tells you nothing is happening. Go get the tape measure now if you want. I'll wait. Okay, now the part I actually made this video for. Why that number can see something your blood test structurally cannot. In August 2024, a Stanford team published something that changed how I think about this entire topic. 108 adults, ages 25 to 75, followed for up to nearly 7 years. Tens of thousands of molecules, profiled over and over across multiple biological systems. Analyzed the traditional way, assuming aging is a straight line, about 6% of molecules appeared to change with age. 6%. A quiet, unremarkable result. Then they dropped the straight line assumption and looked for non-linear patterns. 81% showed significant dysregulation in at least one specific age window. Same people, same samples, same lab. One assumption changed, and the dysregulation didn't scatter randomly. It clustered into 2 windows, around 44, around 60, at 44, lipid metabolism and alcohol metabolism, at 60, carbohydrate metabolism, kidney function, immune regulation. I'll be straight about the weakness here, because it's a real one. 108 people from one region is a signal, not a settled fact. It needs replication. And the authors don't claim to know why 44 and 60. They float declining midlife activity. They float hormonal change. Notably, menopause alone doesn't explain it. Men and women showed the same pattern at both points. But if it holds, then metabolic aging isn't a slow leak in the basement. It's long stretches of stability, interrupted by fast reorganization. And that would finally explain the thing thousands of people describe and nobody can measure. That it didn't creep up over 15 years. That it arrived. That something shifted over about 18 months and you've been quietly wondering ever since whether you imagined it. You probably didn't. Relance. And it gets stranger than that. Because there's decent evidence you don't have one metabolic age at all, which is a problem. Because there's a device in your bathroom that sells you exactly that number. In 2023, a Stanford team published a method for estimating the biological age of individual organs from blood proteins. Not your age, your liver's age, your heart's age, your kidney's age, separately. Accelerated aging in a given organ was associated with meaningfully higher mortality risk, and organ-specific disease tracked with accelerated aging of that specific organ. In late 2025, it was scaled up and validated across 3 continents. Organ-level aging predicted disease onset and mortality beyond standard clinical risk factors and beyond genetic risk. And there's a dose effect. The more organs showing accelerated aging, the steeper the climb. 2 conclusions come out of this. They point in opposite directions, and I want you to hold both. The first one is very bad news for an entire industry. A single metabolic age number is scientifically obsolete. You can carry a 70-year-old kidney and a 40-year-old brain in the same body on the same morning. Average them together, and you've destroyed the only information that meant anything. Which brings us, finally, to the SMART scale in your bathroom. Those metabolic age readouts are not measuring biological aging. They're bioelectrical impedance, a small current, an estimate of body composition, and then an algorithm. Consumer-grade impedance is affected by your hydration, whether you've eaten, when you last trained, and the temperature of the room. So when the scale tells you that you have the metabolic age of a 52-year-old and you're 38, and you feel that little drop in your stomach, the honest interpretation is that you were probably dehydrated. That's it. That's the whole reading. You paid $400 to be told you should drink a glass of water. The second conclusion is harder to shrug off. In these data sets, most physical disease associates with accelerated aging across nearly all organs at once. This isn't a local event. It's systemic. Relance, which forces one obvious question. If it spreads everywhere, where does it start? There's a growing case that it starts in the tissue you've been ignoring the longest.
For decades, muscle loss was filed under consequence. You get sick, then you lose muscle. Victim, not suspect. The evidence increasingly runs the other way. Skeletal muscle may be an early site of metabolic dysregulation, not a downstream victim. Reframe it, and everything looks different, because muscle is the body's largest glucose sink. Lose muscle mass and quality, and you've shrunk the storage capacity of the system that clears glucose out of your blood. And it feeds itself. Insulin resistance drives muscle loss. Degraded muscle worsens insulin sensitivity. Round and round. Now the mechanism nobody explains properly. Anabolic resistance. Forget the term. Picture the experiment. A 30-year-old and a 70-year-old sit down to the identical meal. Same protein, same amino acids, same everything on the plate. Then you measure how much muscle protein each one actually builds from it. The 70-year-old builds less, not because they ate less, because the same signal arrived and the response was weaker. Randomized trials show older adults need substantially higher protein doses to trigger the same muscle-building response. And here's the edge that matters. Even very high amino acid intake doesn't fully restore that response when insulin resistance is present. So, just eat more protein is pointing the right way and stopping halfway. Protein is the raw material. Mechanical load is what makes the raw material usable. 2 ingredients. Neither one works alone. That is the single most undercommunicated mechanism in this entire field, and I'll tell you exactly what to do with it in about 4 minutes. One last piece of science first. It explains the person who breaks every rule in this video. Thin, active, and metabolically ill anyway. Roy Taylor's work proposes something elegant, and once you see it, you can't unsee it. Subcutaneous fat, the fat under your skin, is a metabolically well-tolerated storage compartment. Your body is fine with it. But the compartment has a capacity, and that capacity varies enormously between individuals. Go past your personal limit, and fat starts settling where it was never meant to be. Liver first, then spilling toward other tissues, including the pancreas. Which means there is no universal healthy weight. 2 people, identical BMI, identical clothes size, one sitting comfortably under their threshold, the other over it. Nothing on the outside tells you which is which. If you've watched someone slim get a diagnosis that made no sense, this is the most plausible explanation anyone has offered. Clinical trial data, diagnosed patients, medical supervision. And in the Retune study, participants with type 2 diabetes and a normal BMI achieved remission, 14 of 20. Average weight loss at remission, about 10%. What happened inside them is where it gets interesting. Liver fat came down into the normal range. Pancreatic fat fell, but did not fully reach the level of healthy controls. And beta cell function improved substantially, while still remaining below normal. Look closely at what that is. Not a reset button. Partial repair, in the right direction, in a small supervised trial, in people who already had a diagnosis. It's not a protocol. It's not a promise. It doesn't apply to you by default. It proves exactly one thing, and one thing is enough. This road runs in both directions. Which is why the next 7 minutes are the only ones you actually have to act on.